Who in here has written code this year? Ah, excellent, great. Who here has written code with an arrow or a lambda in it this year? Excellent. Okay, well, you guys are all in the right place. Okay. You may not learn anything, unfortunately. Hi, I'm George. The talk last year was well received. I had a lot of fun. It covered some topics, including like reactive programming on the UI that I didn't get a chance to work on in this past year. But for the rest of it, I actually got to go further. And so think of this as the experience report, more detailed version of what we did last year. The big thing that was interesting for me is that, perhaps like many of you, I grew up with a lot of advice and patterns and ways of doing things that came from the OO community. And as you start to sprinkle in these functional programming things, sometimes it's different. Sometimes it's the same thing, but you have to look at it slightly differently. So I think by the end of this talk, you're going to see a bunch of things you're like, oh, I already knew that, but now I sort of know it in a different way. Okay? So last time I joked about boring slides about fun topics. So just to refresh you, I'm going to include a couple slides from last time so you get an idea about where I'm coming from. I think it would be wrong to turn Saturn into what's new in Java 8. That's not the kind of conference that we're about. On the other hand, there are things going on at the lines of code level that bubble up and become very architecturally relevant, or so I'm going to try to convince you by the end of the talk. So last time we talked about a couple of major ideas that are coming from the functional programming community that obviously connect to architecture. So they're on the bottom, the functional composition, pure functions, et cetera. So the first one you've definitely seen from the architecture of pipe and filter systems on the Unix command line. I mean, so that's a major architectural style. The next one is the idea that you would use pure functions without side effects compared to functions that have mutations as side effects, okay? The third one was the idea about statelessness, which we use in the middle tier of our servers all the time. We've been doing that for 20 years. That's an architectural pattern. And immutability, which is a little bit different. Sometimes we do that from an architectural standpoint. People argue that some kind of HTTP, actually don't argue, it's in the RFP, but the HTTP verbs, some of them are allowed to be immutable and some of them are not. The idempotence we used on a project to great effect. A lot of times people use idempotence, for example, when they can't control the rest of the world, but they want their server to just do something once. And so you use idempotence to ensure that you only process something once. And the last one I want to dig into a little bit more than I did last year, so it's a slightly tweaked version of last year's slide. The big idea here is with functional programming, what we've noticed is that the way that we write the code has shifted from a bunch of statements that do things, which is like, as a smart person, as a software developer, you could look at those statements and say, yeah, I think that adds up to painting the fence. But what we have shifted towards is a kind of code that gets closer to defining what it means to paint the fence. So let me go into that a little bit more. So the example I have is, if you want to paint a fence, what you do is you take your paintbrush, you dip it in the paint, you put it on the fence, and repeat until there's paint covering the entire fence, right? And we can sort of reason through that, and that probably works, doesn't it? Okay. But as soon as you ask a different kind of question, like how much paint do you need? Because I would prefer not to run to the hardware store every time I need to, every time I run out of paint. You guys have all done projects involving hardware stores, and you know that the size of the project, one of the metrics is how many times in the middle did you have to make a run. And sometimes you're like, the total work was 2 hours, but it took 3 trips because I didn't have that screw or I didn't have something. So a lot of times it's more valuable to think about, well, what is my model for painting? And I might say, well, it's related to the area, so the length and the width. And then I start to get a little bit wishy-washy and say like, well, maybe white paint doesn't cover as well as darker colors, and it depends how it's prepped. I might need to do two coats or whatever. But it starts to lead you down a path that I find very productive, okay? And then when your code is all done, if somebody else reads my code, they have a good chance of being able to recover what it was that was, what painting the fence was all about. Okay, so that was sort of the summary of coming from last time. So I figured this time we should go even deeper. We shouldn't just skim coat the surface and talk about architecture patterns. We should actually be showing some code here. The first thing that we did, and let me back up just slightly. What we're going to have here is a bunch of what seem like relatively low level, like you're doing this in the code. And when you've seen all those things, I think you're going to be able to then put the picture together and say, I see how all of these little things that are now available to us as functional programming ideas can add up to architectural changes. So here's one. Java by itself, this is all Java. In Java, there's no way to make a class that has data in it that you cannot change. Okay, so by definition, like you can change the data that's in a class. So there are a couple different frameworks. One's called auto value, and another one's Lombok. Has anyone used these before? A couple hands. So the idea here is that you can use these frameworks. You put this annotation at the top that says @auto value, and then in this second one, the static method, it sort of looks like a little bit of magic, but basically what happens is code gets generated that will create a concrete version of this class that has data in it, but that you cannot change. Okay, so you get a customer, in this particular case, with a name, but once you set the name the first time, you can never change it again. Okay? It also takes care of equals and hash code for you. So if you did customer of Bob, that is, if you do it twice, and you say, is customer of Bob equal to customer of Bob? The answer is yes, right? Because it's implemented hash code and equals for you correctly. Does that make sense? Okay, so you've got immutable data at the bottom. So the neat thing that this, the thing that follows on from that is by using these static constructor methods like the .of that you see in these examples, it encourages us to take the terms from our domain, in this case, customers, products, and sales, and put those into the code, okay? And this happened all the time because it was very easy to do these kinds of things. And that had a really nice impact on the code. One thing you don't see here, and it's mentioned over on the side, is the idea of making illegal states not representable. Is this something you guys have run across before? Okay. Big idea here is that if you have a class, and let's say it has 3 fields, and you say, well, yeah, but I know if the first field is set to 5, then the second field will always be empty, right? You've seen code like that before. And you kind of hate having to discover that in somebody else's code, right? So the idea of making illegal states not representable is, for example, in those of methods, you make it such that you could never construct an object that broke the invariance because you enforce the invariant in the constructor, okay? Again, something you probably heard of from OO programming, but it's kind of neat that you can actually enforce it because the object can't be changed after you construct it, okay? So the next thing that sort of struck me about what was going on with functional programming is when I first saw the Guava libraries, which you guys have probably seen before, these are like improved versions of the collections libraries from Java, is that they allowed me to do things with immutable lists, continuing this immutable idea. And I could say things there like in the middle, immutable list of 2, 3, and 5. And what I didn't realize initially, but became very important later on, is at the top is the old Java way of doing things, and you'll notice that there are 4 semicolons up there. What's the big deal? Who cares? Semicolons. The big deal about semicolons is those things are statements, and that means I can't do the trick with the regular Java array list that I can do here at the bottom, which is I'm defining a constant, right? Primes, which has that stuff in it. And because I could make it all one expression, I can define it as a constant, and that's pretty neat, and we use that everywhere. So for example, the application that we're dealing with is, it's not really very interesting perhaps, but we're getting hardware out of the data centers. And so we might say something like, parts I care about equals hard drives, CPUs, motherboards, or whatever it is, right? You can define this list. And now you've got a constant in the code, and it's been nailed down. It's never going to change, and you don't have to worry about it changing or somebody accidentally bumping the collection while the code is evolving over time, okay? So another thing that's happening in Java 8 and future versions is that there's this idea of streaming, okay? And so what you do is you have a regular collection, like in this case customers, and when you invoke the stream operator, you can put a bunch of operations that come after it that transform the collection in a stream. So in this particular case, we start out with the customers, and we're going to filter out ones or we're only going to include the customers that are premium. And so the way this works with the lambda there in the middle, which has the arrow, it says, if I have a customer, I'm going to invoke the method customer is premium, which is going to return a Boolean. And for any customer that returns a Boolean true, I'm going to keep that in the collection. And if it doesn't return true, then I'm going to drop it out of the collection. Okay? And so there's a whole bunch of operators that work just like this stuff. Now, one of the things that we do with this is we say, look, there's a lot of mechanics in that statement, right? There's just a bunch of blah. It doesn't read very nicely. So one of the things we do here is that you can put in a reference to the method itself. Okay, so what that says is there's a class customer, and there's a method on it called isPremium, and the compiler is going to make sure, if I type this, that isPremium returns a Boolean, because the filter operation is going to require that that thing has a Boolean. And so you can see by applying it, yet another one of these little FP ideas, this code just reads a little bit better. Customers stream it, filter the customers that are premium, and collect it into an immutable list. Okay? It almost reads the way that you would explain it to your friend. And that's a common theme that you're going to see here, is that what we're trying to do is the way you want to explain it is the way you want the code to read. You don't want to be, lambda this and all kinds of crazy stuff that where all the mechanics are getting in your face. So what we ended up doing is we ended up building up a domain-specific language as we went. So continuing that example from before, where we were talking about the premium customers, here's a possible implementation of that. It returns a Boolean. It's called isPremium, takes in a customer, and what it does is it returns if 5 is less than all sales, stream all the sales, filter the sales, here comes a new lambda. If the sale.customer equals the customer that was passed in, okay, great, I'll keep it in the stream, and then I'm going to count the number of things in the stream. Okay? If you guys are a little bit grumpy about this code, you should be. Because, the thing is, it's as simple as if you've got 5 sales, you're a premium customer. That's what you want the code to look like, right? That's what you want. And so if the code doesn't look like that, you haven't really built up the domain-specific language that you wanted, right? The domain-specific language that you were using with your friends that you were chatting about is not the one that you have in your code, okay? So we can work on this. The first thing we can do is, of course, get rid of the constant in the code. And it's because the 5 really represented some sort of, and maybe you'd name that even better than I did, but the point is like the threshold for becoming a premium customer. And then the next thing I'm going to do is I'm going to take that stream that was inline, and I'm going to give it its own method. And I'm going to call it sales count. Okay? And so what I've got now is I've got a method isPremium is if the premium threshold is less than the sales count, then they're a premium customer. And then somewhere else I say, well, what is the sales count? Oh, well, the sales count is you take all the sales, you stream them, and say, those are the sales for that customer, and then you count it. And you're like, okay, I got it. Okay, and by the way, I have to admit that I wouldn't have written the less than operation that way. I would have done if sales count is greater than the premium threshold, but it just made the slide build a little bit easier. Okay? But you guys see what I'm getting at here is that what we did was when we noticed things getting clunky, we're like, we want to refactor that and move some methods around so that it reads nicely, and we get the functional programming stuff out of our face, and it starts to read like natural language. Oh, by the way, some of these ideas come from Michael Jackson's book, Software Requirements and Specifications, and if you haven't heard of this book, just put it in your cart now. I will not be offended if you do it literally while we're in this talk. It's great. So the advice here is that I think that we should be growing these domain-specific languages and improving the expressiveness of the code the entire time. And whenever we find verbose or awkward code, like I just walked you through, just go ahead and do the refactoring right there, okay? Because what happens is if you have to do a sales count method, somebody else has to do a sales count method. What we ended up doing is if we couldn't put it on the object itself, like on the customer object, because you might have noticed that the sales count was using data that the customer didn't have, which was all the sales. You can put it on another object, which might then know about both. So one convention we have is we put an S on the end, so like customer becomes customers, and then a whole bunch of methods relating to customers go on that object. Not any individual customer, but they could work across them. So the thing is that some domains are already pretty well worked out, like banking, right? People already know what all the terms are, they know what premium is, et cetera. But in most of your domains, you're going to have to do a lot of work to come up with this language. And what we found was that this is one of the most difficult things on a team And the domain-driven design guys talk about this all the time. Your stakeholders may give you vague terminology. They may give you conflicting terminology. They may not give you all of the concepts that you need in order to get this domain-specific language to work out well. So what we did inside of our code is that we wanted to separate two different ideas. One was, when we're making statements about the domain, right, customers and accounts and that sort of stuff, we wanted to keep that separate from the mechanics of like remote procedure calls and data structures on disk. So what we did was we literally had in one package things like customers, products, and sales. And in another one, we had things like the request and response objects that we would have for remote procedure calls, or proto, short for proto buffers, which is like a JSON-like format that you can put the data in, perhaps on disk or perhaps inside of a remote procedure call. So by separating those two things out and being really strict about it, we were able to say things in the domain on the left, the problem domain, and keep all the language looking really nice. And then in the other domain, you have all the vocabulary that comes from, well, about retries and timeouts and all the other things that are phenomena that are happening with remote procedure calls or storage. And so the way we made those things work is that we made converters between the two. Now, converter is an interface that comes from the standard Guava library. And you'll notice with the angle brackets there, that's a converter from a customer to a customer proto, and you can also run it in the opposite direction. And you can even imagine what this code looks like. You know, you've got a customer class on one side, and you've got a proto data structure on the other, and you're really saying this field corresponds to that field, and this enum corresponds to this one. And of course, you know, it always starts out easy, and then it ends up being like almost a proper parsing problem to get all that stuff straight, okay? So what we found was that by being strict about this, we ended up, sometimes we called it wiping your feet at the door. You would get all that stuff. Number one, you'd know that it was in the converters. Like if you said, where does this data get transformed? It's in the converter. And we keep all the protobuf stuff out of the problem domain, okay? You guys have seen this pattern before in various different technologies like the hexagonal architecture and things like that. Okay, so in some ways, what I've been describing to you is old hat. You're like, I've seen this stuff in OO programs, but notice that there's some spin on it that's a little bit different. I mean, the objects are immutable, and we're talking about building up a DSL. Well, I know about that kind of stuff. But our DSL has, for those domain objects like customer and so forth, we've got predicates on the state that return things like true or false about is it premium. We have some query methods we saw like sales count, okay? And then we might have transformations. And by transformations, it doesn't mean the customer itself changes, but you might say, if you had a customer and you had, let's say, a product, you could create a sales invoice, okay? And anytime you gave it the same customer and the same product, it would always transform that into the same sales invoice, okay? And so that's the stuff that we did build up. Interestingly enough, this is what sometimes is pejoratively called an anemic domain model, right? Because you're not pushing all of the functionality down into it. We're only putting some things there. So specifically, mutation and business logic are not in that domain model, okay? That's the pattern we settled on. So the way that this is traditionally described, for example, if you read Martin Fowler's books on enterprise application design, is that the tension was between one way of doing things, which was the really rich domain model that has, you push all the behavior down into your domain model. And then the other thing was the transaction script. Transaction script would say, I'm a server, I just got a message, I deal directly with the raw messages, I like poke a few things and then return a result. Okay, so I don't invoke a rich domain model. And so what we did was we had a compromise where we pushed some things into this rich service layer and we left the anemic domain model alone, okay? So our domain model is a little bit different though, or at least it's stricter. Again, immutable. There were not a lot of optional data fields. So in other words, we wouldn't say like, well, the customer might have this and it might have that and it might have the other thing, which you would see in JSON, right? Like it's a very loosey-goosey kind of data structure definition. Ours were very strict. We had integrity checks at the system boundary. Those are the converters, right? So if you gave me this proto, either it will or it will not convert in. It's not fuzzy. And it has less behavior in this model than in traditional OO, okay? So this led to the next thing, and maybe this is kind of obvious, but when you're doing some data processing, there's some sort of, I need to get the source data, I need to validate that the source data is reasonable, and then I need to do an operation on it. Okay, this is like, you're doing anything with an IT system, there's some pattern that looks like this. Now, in the old days, all three of those things would be happening in my domain model, and that's the kind of advice that you'd often see from domain-driven design community or in Fowler's enterprise application stuff. But the difference here is that last step was often, we were factoring that out of the domain model, and that first step was not actually in the domain model either. It was in some sort of gateway pattern objects there. So that was the big description of like how the functional programming ideas affected our code when it came to where does the logic live in the application. Okay, immutability was everywhere, pure functions, and the domain model didn't have the main stuff. Now, many of you here, like you all raised your hand, many of you understand the arrows in the code, so you're not going to be afraid of monads, but others may have a little bit of fun. I'm going to show you two monads here that we used. The first one's built into Java. It's the optional monad called maybe in some other languages. And the idea here is that you can avoid having nulls and null checks in your code if you use optional. So take a look at that first line. I go to the customer data access object and say, for example, get customer number 5. Now maybe customer number 5 exists, in which case I get an optional, it's like a box, that has the customer number 5 in it. But if the data access object looked it up and found out there was no customer number 5, it's going to hand me back a box that's empty. Okay? That's what optional empty means. Okay? So the advantage of this is that in the second line, you notice there's no null checks. I can just say customer address zip code, or else I get missing out of this thing. Actually, I think I was typing these slides and I realized I actually have to have a map operation in there. I did that slightly wrong. So the result of doing all this stuff is essentially we get almost no null pointer exceptions in our code, and that was wonderful, right? But you need to follow this particular pattern. The thing is, though, we ended up sometimes with some really ugly code. And we would have really ugly code that looks something like this. Let's say I need to get a valid customer. Okay? And I'm not necessarily saying this is the best pattern, but it's easy to fit on a slide. Okay? Sorry, that is the valid doesn't make a very good contract. And I like methods that have really nice contracts. Okay? So valid is kind of a loosey contract. So in any case, let's say in this case a valid customer, you have to have a customer, the customer has to have an address, and the customer has to be active, whatever that means. They're a current customer of ours. And so your first naive version of this with nulls looks something like this. Does this look familiar to you guys? Like a lot of IT applications follow this same sort of pattern. Go get the data, check to see if the data's there. Okay, you got the data. Now you can safely call a method on it. Call some methods on it, make sure that looks good. If everything's fine, you probably have multiple return values, return points from the method. Okay, so we should be using optional, right? Okay, so, I hate writing this code, and I hate reviewing this code even more than I hate writing it, okay? So I've highlighted in yellow the changes that we had to do to this code to get it to use optional. Okay, so here's optional. We have optional if customer is coming out. We have optional if customer coming out of get customer now. And what we've got is, we could actually do this in a slightly more idiomatic way that I saved in this example, but basically you're still doing the same kind of checks, and everything still looks pretty similar. Not really great. It's slightly more verbose than the last version, actually, okay? So what we did was we invented another monad. It's derived from ones you'll see elsewhere, and it's called the try monad. And the way you can think of optional is either you got it or you didn't. The way you can think of the try monad is either it's successful and you got it, or it was a failure and you didn't get it. Okay? So almost the same as optional, but not quite. So in this case, what we do is we call that same get customer, which returns an optional. We wrap that in a try, and if the optional was empty, then the try was a failure. Okay? And then we continue along in the program. And it doesn't really look much different, except that we've changed from is present to is failure. So we can do better. We can implement a method on the try called CheckState. And the way CheckState works is, imagine you've got you called and you got a customer number 5, you're holding on to it. You're really saying, I'm going to consider this customer number 5 to be a failure if it doesn't have an address present, okay? And I'm going to consider this thing to be a failure if the customer is not active. Does that make sense? And so you can already see that we're starting to get the boilerplate out of the mechanical jumbo, like you're getting closer to reading the intent, okay? Which is that get a customer, if he's there, make sure he's got an address and that he's active, okay? But we can go one step further because each one of these guys in CheckState, those things are just predicates. So we can convert the predicates into the much nicer readable form, okay? And if you look at what we've got right now is, you've got a method definition that started out like full of junk and if statements, and we've now turned it into 3 lines that don't have any branching, okay? It reads reasonably well. I mean, once you get over, like you have to get your brain around the idea of how tries and optionals work. But for the most part, you're looking at this thing, you're going, okay, try from an optional of getting a customer. I'm going to check state that the customer has an address. I'm going to check the state that the customer is active. Okay? I mean, like it almost reads like the way you would explain it to somebody. All right? So what we found was that this works great as long as you don't need to branch. And by branching, I mean things like, well, I need to make sure that the customer is valid, and then I need to make sure that the sale is valid, and then I need to do this, and I collect all that stuff together, and then I'm going to do some more transformations on it, okay? So what you ended up with is collecting a whole bunch of optionals or collecting a whole bunch of tries, and then you're going to try to filter, channel them all together and then keep going. And Java just doesn't have the mechanics for doing that. It's not conceptually difficult, it just, your code ends up looking ugly. But for code that's like this, that's sort of straight through, it works very well. So what I like about this is that the null checks are all gone, and as far as I'm concerned, like once you get over the try hump, I think you can see the logic in this very easily. Okay, end of the boring slides. Maybe. So one of the things that I really like about using FP in this particular way is that it helps me express the intent better of what I'm trying to do, okay? I like using the fluent streaming operations because it gets closer to customers, filter out the ones that are premium. Like I'm getting closer and closer to not having the mechanics in my face of iteration and so forth. I like using the domain-specific languages that over time the code gets more and more expressive of what I'm trying to do. In a workshop a couple days ago, Michael was asking everybody who has been on a system where you've got things all sorted out in the design so well that a new requirement comes in and you're just able to like make very small changes to the system to add that feature. And most people had said yes, but that it was an uncommon experience, right? Because usually the code is not quite ready for that requirement. EPEC and some other people are writing a book on technical debt. And in some ways you can think of technical debt as the code is not ready for that requirement, right? It's getting the job done from yesterday just barely, but it doesn't have this domain-specific language going. So I would say try to grow the DSL as you go, and don't forget about how tests read. One of the things that we did that was a mistake is that our main code kept pretty clean, but our tests kept getting uglier and uglier as time went on because we're trying to express, for example, in a DSL that wasn't helping us, what the initial conditions were for the test. And when we actually did some work on the tests now read just as well as the main code, and it's a lot easier to work on that. So one of the ways of thinking about this stuff is if the code doesn't read as simply as like sales count is greater than the premium threshold, then really what's going on is you need to do the work somewhere else, right? You need to be doing the work on the domain-specific language so that the thing that I'm trying to do right here becomes easy. And the easy failure case that you see a lot of times, especially with developers that are very excited about functional programming, is that they just want to like solve the problem right there. And so that you end up, well, one of the code smells is that the code starts to march to the right with a bunch of little lambdas and it's like, I believe you that this works, but I don't want you to check this code in, please, because like you're solving the problem here, but you really should be solving it somewhere else. Maybe there needs to be more predicates on the customer, for example, right? Or another function somewhere else. So here are 3 specific examples of code smells that I notice myself commenting on that I try to get on. So the first one is, if the code that I'm looking at has lots of primitive or simple types like integer and string, that's usually an indication that they haven't thought it through well enough, right? So for example, that integer might really be the customer ID in disguise, and the string might be the address in disguise, okay? And with the use of auto value, making it super easy just to define a class called customer ID and stick the thing in there, there's no excuse not to. And at first I wasn't completely sold on this pattern, somebody else was pushing it. But now once I've tried this, everybody who tries it is like, oh, I can't believe I ever did this before. Because you don't have this situation where you've got a method with 3 arguments on it, which are int and string. Instead you have, customer ID, sales ID, and something else, right? Like they all have real types to them. So another observation I had is, look, you're telling me that this thing is an integer. If I'm not allowed to add to it, it's not really an integer, right? So for example, you can't take the customer ID and add 7. Like, my program is going to go crazy if you do something like that, right? So that means it really isn't an integer. Don't give me a method .add on something if I'm not allowed to add, okay? So the second one is that I would see code coming my way that, again, people had a problem, the model was not in the right shape for it, and they just started pushing harder by nesting these angle bracket parameterized types. So in this case, a list of a map of a customer and money. Okay, so you just need more types in there. So one way of thinking about this, if you think about that example specifically, like a list of a map of customer to money, well, maybe the map of customer to money is like a ledger, right? Okay, these customers have these balances or something. Maybe that's a ledger that I'm keeping. Okay, well now I have a list of ledgers. That's great, no problem. List of ledgers are no problem in my system, okay? So the last one is, it basically is that marching across the screen stuff. Watch out for complex or tricky functional transformations, right? Like the code that you're seeing here today is the code you want in the system. It's the code you want to be writing and the code you want to be maintaining. You don't want to be like looking at this stuff saying, wow, this just barely works, okay? I'm very impressed with your functional kung fu, but please let's not do that. So at some point you got to be asking, all the stuff I've been talking to you today, is any of this stuff really architectural? And as you can see from this highly precise chart that I've developed, it's got 0.0. That just came out of the charting tool. So I found it amusing. I'm like, I don't know why you give me 3 digits of precision on this, but all right. If you take a look at our system overall, it's so different than it would have been a couple years ago before we adopted these patterns, right? Like all that blue stuff would have been all just traditional mutable objects, okay? And so you say like, this is a big impact on the overall system. And that's even before we get into some of the other design decisions. But just even if you think about the immutability aspect, it's really a very sweeping change. So in summary, on the left-hand side, these are the set of patterns that we applied. Okay, we already saw these streaming features like that collection pipeline. We got rid of nulls and we used optional and tries instead. We used a domain model with immutable data types using the auto value. You guys could also use Lombok. We didn't really get into this, but we were very strict about not creating illegal instances. We made it so that you couldn't represent illegal states. We built up a domain-specific language over time. This lookup validation and operation we ended up separating, and we put them in different places than you probably would have in a regular OO program. We pushed things to be declarations instead of a series of statements. We saw that just a little bit here. The rich service layer, we think, by the way, there's got to be a name for this pattern. I haven't found it, so please let me know later on and we can start using the standard name. But yeah, the rich service layer says, the guts of the business logic probably is not getting pushed into your immutable objects the way that we would have advised people to do in OO 10 years ago or something. And then finally, with the converters, we did the parsing at the system boundary. If you think about the program that we just built, let's imagine that we've solved that problem, but we need to do something else in the same domain, okay? You could say the interesting bit is the domain model that we built up represents stuff that the business probably thinks is true. Like there are customers and there are sales and so forth. To some extent, we've already seen success in our field of reusing that domain model across teams. The second thing is that these converters to and from external representations may be another thing, right? So if there's a service that you're talking to that has customers, right, and you need to copy from their format to your format, that's a reusable thing that you could use later on. And then finally, the machinery for doing the remote procedure calls of going out and collecting that stuff and bringing it back, that also is potentially reusable. Okay? So I think that we might have a really nice set of Q&A after this. I'm kind of looking forward to it. Please ask me about stuff that goes way beyond this, because there's a lot of things that go into this, right? There's a cultural change to this. I mean, there's impediments in doing that. There's expressiveness limits in some of these things where you might say, it's really cool, but like you're confusing everybody by doing this. So ask me anything, and thank you guys for your attention today. The question was, does asynchrony affect this in any way? That did come up on our system. It comes up a lot of times when you're trying to make a highly available system. And so a traditional thing is you don't just run it on the Amazon East Coast data center, right? You run it on the East Coast and the West Coast and probably one other one, okay, just in case. So you end up with a situation where a message comes into your system, it's getting routed to one of those instances, okay? And we did actually run into troubles where through surprising configurations, it got routed to one, it took longer than expected, something figured out or thought that it was stuck and so routed it to a second instance. And so, yeah, you can end up with that. Yes, you can run into troubles. I didn't get any automatic wins from this stuff. Having immutable data types or having idempotence of the operations can definitely help. At some point, the rubber meets the road in terms of mutations. So in our particular case, what we had to do was we had to write out, say, inventory changes, okay? Or things that were capitalized became uncapitalized and things like that. So there is a mutation that actually happens at the end of ours that was impossible given the APIs to make idempotent. So we had to be sort of careful that we didn't end up processing the same message twice. We had to put the do it only once on our side of the system rather than on the other guy's API.
Have you looked at closure and the style of closure applications?
I would be delighted to learn. I mean, I've seen Rich Hickey's lectures and so forth, but I've got a friend who's like a giant fan. But no, we end up having a handful of languages that are allowed to be used inside the company. Closure's not on the list yet. But I think I could probably end up learning a lot from the patterns they're using.
I'd love to chat about it because I see some resonance between the way that we've been building things in Clojure and what you're describing here. So there seems to be some deeper pattern.
Yeah.
Way to be, identify that.
Awesome. Let's keep chatting. Yeah, I have to admit, I kind of feel bad chatting about this stuff here because, look, the domain-driven design conferences are talking about this stuff. You can find blog posts about people saying F# is a perfect language for doing domain-driven design because you can do exactly this kind of stuff. But I figured it was experience reports are always welcome. And the fact that this one's tailored specifically at Java is kind of helpful because many of the early adopters are in other languages that are more expressive, that have more embracing of functional idioms. You can do a lot of things in Scala, right, for example, that you couldn't do here. So in some ways, like reporting on what was harder to do is also a bit interesting. But yeah, I'd like to chat. So the question was about patterns for asynchronous collection of data. So when we started on this, we did not know the domain, and we did not have really strong guidance from the business people to explain the domain to us. So we were learning the domain as we went. There are frameworks inside of our company for efficiently, at the beginning, basically setting up a graph of dependencies, saying like, I'm going to need this data, and that's going to add up and make this data, and which is going to get put together with this other data, right? And you can sort of think of that as being, that graph being a static description of what all those asynchronous calls are going to look like. And so you can set that up and say, go get me that stuff, right? And then you either get the result or you get a failure, okay? We decided not to go down that path with this application because it ends up being, you have to worry about reasoning about that asynchronous stuff at the same time you're trying to learn the domain. And so we decided it would be better to do it slower and we'll call it wronger by sequentially collecting the data that we needed and then doing the transformations. So we don't have experience, I don't have any experience to share with you on that, but I will say it definitely allowed us to learn the domain by doing it the low performance way. Performance wasn't so much of a bottleneck for us, but if you were doing a high scale service, then you definitely would want to make sure you're not linearly collecting your data. You'd collect all of it and then do the callbacks or something else.
Who are the, I guess, who are kind of the champions or the biggest advocates for this? Like, who's kind of driving the change? And then, I guess, the opposite of that, I guess, how would you go about identifying those champions? And then sort of the opposite of that, who do you find are the types of people that are kind of resisting change, and how do you deal with that?
That's an interesting question. You're saying, who are the champions, who's driving this stuff? At the beginning, I imported a bunch of prejudices from a previous team, and I got a few other people excited about those things. There were people that were already excited about functional programming, so I sort of had an easy group of champions to start with, okay? But you're absolutely right. There were several people that were like, I'm not really ready to do this kind of stuff. I'm not really excited about learning a bunch of new functional programming idioms, okay? Even if it ends up better in the end, at the beginning they were not very excited about it. Especially when they saw some of the people writing the crazy code that was marching to the right and like you can't see why it works. I can mention one example we had that was kind of surprising. There are people that like to write really tight code, say call it like programming competition code. Okay, so we had one of those kind of people, and he would be like, what you're doing is slow and stupid and whatnot. And so he had like, you know, raw Java arrays and I++, you know, and I'm just like, I do not want to review your code because I don't want to have to figure out whether you have an off by one error, and you might not. But you're putting that on me as your code reviewer. And I'm like, but when you do the stream of this thing and then say filter out the premium customers, I just categorically don't have to worry about if you've got the termination conditions and whether you're ever off by one in your, you know, allocation of your array sizes. Your code will probably run faster, and I could always take my code and refactor it to yours, right? This is the premature optimization, the evil, you know, the root of all evil. Anyway, so sort of roundabout on that thing. It was a bit of a challenge to get everybody on board, especially with the DSL, because they're always excited to just put the Lambda right in line. But slowly but surely, we've been socializing the idea of like, that isn't where that Lambda goes. It goes on an object somewhere else.